Okay, good afternoon, everyone. So as you know, this talk will be in French. No, I'm kidding, but I'm coming from France. I'm in US since several years. And I'm going to talk today about Perl dependencies on memory. And so this is a talk that I prepared lately because I replaced someone, and I am aware about this since Friday evening. So sorry for the poor quality of content on slide. I'm going to do with what I have. So no, this is not TAP-CNA. Yeah, we should call it now TPC. So this is TPC. So we're going to discover ink, add ink, %ink, see what we can do with these list dependencies, see how we can go further by checking memory of a process, trying to combining both to do some fun thing with this, and then see how far we can go with this. So all the slides are currently on GitHub on a very simple repo. You can download them from there. You also have the samples, the content, everything is there. And I will probably also add a link at one point on the YAPC website. So let's play with %ink. So we have @ink on %ink. And the first thing, we should not confuse them. @ink is where we are going to look for new modules when we need to load some, whereas %ink is what we already loaded. Okay? Two different things. So let's have a look at this with a very simple program like this. Let's display the content of @ink on the content of %ink. Okay? So this is what I have. I'm using strict on warnings. So in %ink, I can see strict on warnings PM. And I can also see where they are coming from. And whereas in @ink, I can see my my Perl5 ink and where I'm going to load module from. Okay? So two different things. Now let's try to add a new module to that script, like use findBin, because I will need to use it later. Oh, more than one PM were added to the %ink. So just loading findBin, I can see findBin here, but also a lot of dependencies coming from findBin that I was probably not aware about when I just say use findBin. So now let's say I'm creating my own package, very simple package that just say hello world, and I'm including this in addition to my original program. Same thing as earlier, but in addition to this, I can find my package here. Okay? Now let's see what happens if in the same module you define two different packages. How does it behave? So at the end, %ink will be only populated with the file name, not the package. Okay, just the module. And the module is there, multiple packages, and only 1 or 3 was added. So how can we list? So in fact, this is the dependencies. How can we use this to list dependencies, for example, from this program or any others? One of the goals would be to list the dependency without updating the source code, the original source code. I don't want to update the source code, and I want to list the dependency. So here's a simple idea. Let's do that inside a check block that I can run using -c, Perl-c, and I will I'm blacklisting myself. I say, okay, if it's me, don't care, don't display it, and then display. Let's have a look. Of course, I need to exit the full screen. Okay. Okay, this is a hello world I was showing to you. And now let's use that module using the D to load that devel module. So here it is. So
Can you make the text larger, please? Thank you very much.
okay. So I'm just loading the module. I'm using -c, so I'm not running the code. And I can see syntax okay, but I can also see the check block which is executed there. Now let's try to do this with the other that was using more than one module. Oh, cool. They are all there. I can list dependencies. Okay, but that syntax is not very convenient. Let's try to wrap this in a simple script that I would be able to use much more easier. So this is a simple program where I'm just going to provide it a list of files. Okay, and for each file, it will be either a file of a module. If it's a module, the file will not exist, so I will just use Perl Doc. Yeah, some do not like this syntax, so I use this to get the location of the file. And then I'm just using the same command I was running, the current pair. This is mainly from my debug version there. And I'm listing dependencies, and I will print them. Yeah. Nothing special there. Let's just try to improve it. This is just slightly improved version where I will be able to use dash files. If that dash file is available, I will convert the PM to I will convert the PM to the namespace. That will be used later. Okay? So we can list dependency. Let's check out what we can do for the memory profiling. So I came by with just this one-liner. This is working. Yeah, so the important thing is the single quote, and do not use the double quote there, of course. And the idea is that we want to check the RSS of ourselves, which will, by reading /proc, which on a standard Linux system will exist. So this is the memory when I start this one script. Let's check if it's consistent. Normally, it's about this. It's, at least I can use this matrix to do something. Now let's check what happens when I load a module in that one-liner. Or I can see, oh, I'm using 1 extra meg of memory in this one-liner, but just including carp in that. Now let's check if it's also consistent with carp. Yes, it is. Cool, that sounds good. Let's try from one module to another one if the price to pay is about the same or not. On second I load data dumper, then, oh, they will be bigger than carp. Interesting. And I try with other module, config, digest, and code, and we can see that the size differs from one to another one. It's good to know. So now what happens when I combine them, when I try to load more than one module? So this is no module, just config 2.6, config and encode 3.4, encode config on PPI, oh, nearly 10 meg, and using test more, 10 extra meg, using moose, and this is a 23 meg that I'm going to pay at startup just by loading this module. And if you want to have fun, you can probably try to include your full pair stack to see how much memory you're going to use by just preloading all your modules in a one-liner. It will be pretty fun. So what is the impact of using features or not? No features, and I'm using the capital E to import them. It's about 300K, not so bad. Let's now check what happens when I'm importing function from a module. So when I say use net IP parents, I'm importing nothing to that namespace, which is about the same as using require. And yes, metrics are also about the same. Now I import function from net IP. I import, in fact, default function from net IP. Memory, slightly bigger. And now I say import whatever I can. In fact, I need to say proc, not all in net IP. And this is, again, a little bigger. I could have probably find a better sample than net IP, but I just use this one. Let's have a look at exporter, which is used by net IP. So this is an extract from the pod of exporter, which definitely explains when you are going to say use your module, the default function will be imported to your namespace. When you add the parents, you disable the import. And then you can also specify on-demand import using, for example, a code word there. So in net IP, this is how it's coded using exporter. Just saying it's in exporter, the default export list on function we can export. Unfortunately, I probably do not have this on the screen, but there is a rule where it defines the special keyword for importing. So all of this to say that when we import by default from a module, the script running will use more memory. So at cPanel, where I'm working at, we came with the convention to disable import for any modules we are using, which means using parents everywhere you say you use something. It takes a while to be used to. It looks strange at the beginning where we're not used to. But it also has some major advantages. For example, you can easily search in your code base a function, and you directly know which namespace that function, in which namespace that function is called. Or you can also search very precisely for that function in the scope of this package. And this is kind of cool at the end, but this is a prerequisite for all the tools I'm going to show later. Yeah, the one-liner I was showing you, unfortunately, is not working on my Mac, so I need to come with something slightly different for there. So this, in fact, I only need this for the purpose of this talk, because most of the time I'm not on, I'm working on Linux server, not on the Mac. So I came with this one-liner, which is pretty correct. Oh yeah, it's working. Second time, you see, the regular one-liner, then I import answer to 22. Cool, it's working. But no, it's very bad because it's definitely not as consistent as the Unix version. I should probably come with something better than this one, but this is not the purpose of this talk. Now let's try to have a simple helper using this to be able to get the memory of a module or a script. So same thing, you can probably just use the first line. If most of the time you're working on Linux, it will work. And this is just for this talk, I'm using the else there. So I put this code inside a devel module, and then when I use it, when I load it, for example, loading test more, just doing E1, I can see that I have 4.8 megahertz for RSS. And I've got that E syntax, okay, let's get rid of this. Okay, I don't care, redirect this to devnul, and not the extra space there. Okay, let's also remove it by simply casting to int, and that should work in most of the case. So we can run it using a module, or we can also run it using a script. And it will work in both cases. So this is the devel PM. Okay. So the same thing, exactly same thing as previously. This syntax is pretty easy to use on a common basis. I just want to come with something easier to manipulate. So let's wrap this in that simple file where it will automatically take the arguments from me and do the code. Nothing really magic, I just get the file and I run it using the process memory thing. Let's try to run it. Cool, it's working. I've got some memory for my module on my script. I know how much memory they are using, at least at startup, at the beginning of init, beginning of check, sorry, which is just before init. I can also slightly adjust the script to do some, to use it using multiple files and having a report that I will be able to use on probably adding any extra tools later. Okay, so what we currently have, we have a tool that can list the dependencies, but we also have a tool that can list the memory used by a module. So from this, we can probably try to build other things on top of this. For example, we can simply generate a CSV file and use it in your preferred editor to sort them and whatever to track what module is using the most memory. And we can also analyze the evolution of memory. depending on your version, depending on the Perl version you are going, any kind of thing you can think about. And I'm going to show you an extract of a tool we currently are using, where when we switch from Perl 5.14 to Perl 5.22, so this is a Dancer web app. We have, for example, all the scripts on the left. I can click on the script. I see the list of modules there. I can see how much memory it was using in 5.14 and how much memory it's using in 5.22. This is exactly the same code. These commands are running live when I click on Dancer, using just 5.14 and 5.22. And I can see that some modules are using much more memory than the average. Maybe there's a cost to pay when we switch from 5.14 to 5.22. I would say about 20% more memory. But in some particular case, there might be some interesting thing. You want to investigate what are you doing there. It might be a regex where you are using something that will watch Unicode. It might be other things, so you need to know. And the good thing with this, for example, with this UI, you can also click on a module and then list the dependencies of this module. So you can, it's very, very, very useful to track memory in your code base. So let's check. Okay, this is good, but can we do better? Because if I know that a module is using 5 meg of memory, I would like to at least have a guess or information where that memory is coming from. So I came with that idea of, let's say, details, just a improved. So I'm going to run the details that I'm going to show you later on that use sample modules PL, which is just a simple script with a use foo bar on a. OK. Cool. The idea is that I'm showing the memory. Probably it's not working as I would like, but this is probably normal. Cool. Here it is. So I'm running this script, and I'm inside a debug module, and the idea is that each time I will see a use or require statement, I will run the RSS check. This is very easy. By running the RSS check, I can display what's the total RSS currently, and what is the delta since the last run. And I know where it's coming from, I know which file, which line it's coming from, so I can display this information. Pretty difficult to read like this because I have the full path. Okay. And what we can notice also is that the total here display at the end, for example, 62K, I think if I use the non-details version, oops, okay, now I need to do C, whatever. Yeah, it's using more. So what I would like to show you is that the total using the extra information is higher than this one. I cannot compare these two numbers because I'm in fact adding some extra pollution to the namespace when I run it there. But this is just a metric. So when I'm comparing the same thing, it will be fine. Okay, and I can run this on data dumper. And same thing, I can see the memory of data dumper. I can see clearly, for example, let's here, XS loader is added by data dumper at line 33. So if I open this file, line 33, or not, okay. Probably. Okay, it's not there. Okay, that's the idea. Okay, I don't know why I cannot open, but okay, let's continue. So same thing, this is not very convenient. Let's wrap this in a script where I will be able to say, give me the memory or give me some details for that script or module. So exactly same trick as earlier, except this time we're going to call the different module, list depth details, and I can even bypass it if I want to do if I don't need details, then I can simply run it directly. Okay. On the frame, it will be too small there. Okay. And this is how you can get the details using DB. Probably going to open it somewhere. This is not the one I want. Oh, this is this one. No, this one. Okay, I don't know where it is. What I was looking for. Okay, let's try to zoom. It's very small. I don't know where is this file. Okay.
You could just tell us about it. We'll believe you.
Yeah. The main idea here was to show you the code that checking the modules one by one when we are reaching a require or use statement. It's just using a devel module. Anyway, that's not the whole point. Okay, continue. So this is now with the wrapper, when I run this tool on, for example, data dumper, I will be able, so now I also improve it by removing the prefix by checking what is in @inc, which is, will then give a better name, so you can clearly see where it's coming from, what you are loading, where it's coming from, which line it is, on the delta memory added. So you can probably investigate, do you really need this or not? Same thing on use modules. Still small. Okay, let's see how it goes. Okay. Okay. So this is just a simple script. Now I'm going to profile this one. I've got on the script, I run it on the display the memory here at the bottom. Okay. So I'm going to run it on this. Oh yeah, we should probably have seen what is use tool. Oops. Yeah, use tool is just use tools. From tools, I'm calling a few functions. Okay. So now I want to make it smaller. So I've got a use tool patch, which is not the same one. How can, without patching the modules, how can I make my script smaller? For example, in this case, I'm not using the tools dump, which is using data dumper. I don't need it. There is a big library file. So this is definitely, you definitely need to know what you are doing, because here what I'm doing, I'm just saying data dumper is already loaded. Do not try to load it. I really know for sure that in the full cycle of the program, I'm not going to need it. So, for example, here, I'm going to reduce the memory of that tools PM by avoiding the bloat of data dumper on cap. But tools patch on the tools unpatch are both using the exactly same tools PM. The only difference is that big in block above that will, so here, without patching tools PM, in fact, I've just disabled the data dumper here on carp, which is pretty broad by data dumper at one point or the other, because I know that I was not using this function. So if I'm able to do this in a way or the other, I'm going to save memory. I'm not saying that dump is useless in that tools PM. I'm just saying the context of this program, dump might be useless. And it will be good for this program, I'm just able to remove dump. There might be some saving behind the hood. So, yeah, we show that we can blacklist a module. And I say, do not do this. In some cases, when you blacklist a module, some functions are still required. If you really know that you don't need it, you can also mock them and disable them. So from there, we see that if we remove code, we are going to make our process smaller. So first thing I did, Google detecting dead code Perl. By the way, there was also another talk about detecting dead code earlier today, which was using the op tree by creating a different op to detect code once run. The idea is now to use PPI, which is a different direction. Of course, there is more than one way to do this. So I was interested by the second result, which is from Brian DeFoy. Here is his blog and article where he's using PPI to detect unused code. We're going to show it. But he's also mentioning another attempt from Ovid. So let's have a look first at Ovid attempt, which is in fact a shell script, which will probably be the very first solution that you will think about. Let's try to find a sub on which one are used. That might work, but you will clearly it will work short, but you will have some caveats very easily. So this one is using PPI. We are going to try to use it. Okay. So So I've got a sample, which is unused one. Unused one, it's very easy set of function, and I'm just calling G. So G require E, and E require F, and nothing else. So in fact, I just need E and G. Let's run that tool there. Okay. Did I run the same? G, E, E, F. Okay. At least. So it's able to detect all the functions defined in the file, A, B, C, D to G. Detect the used one and the unused one. Probably there are some special. Yeah. So at the end, not exact. It's going there. So now let's go back to that sample where we're using a set of, where my functions are inside a PM. Let's see if I can detect unused code from this file. No, it detects absolutely not any unused function. Why? Because it's mainly doing a PPI analysis of the file and not the dependencies. Okay? We can probably fix this by fat packing the program. If I fat pack it, I will be able then to do probably a better analysis of this. So, okay. I don't want to use fat pack, I want to do mine. Why? Because mainly because it's fun, and I also need only to fat pack the files in my Git repo, only in my module. I don't care about the modules coming from cPanel itself. So we need a name. Yapsi, no, we can't use it. TPC will be a good name, packaging camel, but no, it's also used. Yapack, yeah, Yapack. Yes, yet another packing script. Let's see how it works. Okay? So I call yapack on a script, and the idea is that it's going to fatpack this, and I will have this file there. So it detects that tools PM was used. It added in the begin block in ink, add the tools PM there. Okay? And the most important point is later in the code, it will put back your program and also comment modules that are included in the file. So I can run the fatpack version. It's working. It's doing its job. Now let's try to run the original script from Brian on this one. OK. At least it displays more function, detect that dump is unused, which is the case because I comment this. It detects more function, pretty false positive on begin because we should not try to remove begin block, special keyword. So we are going to try to do ours, okay, by removing on-demand unused code. We are going to detect unused code and try to remove it from the script. What can go possibly wrong with this? Many, many limits. First thing, Perl is so dynamic that if you have a function which is built from scalars, it will be very difficult, not impossible to detect it. And also, methods on inheritance will also raise their own issues. But we can probably try to fight them. So here is here's the version I came with before showing it to you. OK. Here is the process. I take the script, I fatpack this. We have a fatpack version. Then I run a PPI analysis. I say, oh, C is unused. Let's remove it. So then after, I will look on this, so do a second analysis. Once I remove C, I discover that B and D are now useless, etc., until I reach either a stable loop or nothing else to remove. And at the end, I display the list of useless functions. And better, so there is the fatpack script here, and there is the cut one. And I can do a diff between both. I can see the function A, B, C, D in this case were removed. So both scripts should run the same way. So this is the origin, except that it's doing nothing, of course, because I should add should add something in G, in E, in F. Oh, that's probably why. Yeah, my slides are not up to date with. OK. What about this? OK. And now if I try to remove function from this, and I run that, I run the fat first, and I run the cut one, it's going to behave the same way. Except that now, yeah, I've got the same number of lines because they are commented. OK, cool. No. OK. Now let's try, before showing you the code, let's have a look at the unit test, because we have more than one case to cover when we remove that code. So here I have some basic unit test that's going to call the script. So here's a sample fixture, for example. So we have a simple script where I'm going to call either A, B, C, D, E, or F, or G. It should detect the correct one. OK? So when I'm calling this, it's all this. I'm calling with A, B, C, D, and I check the result. defined earlier. That's the first case scenario. Second one, when we have a multiple package. Here I'm calling B1, which is calling foo F2 and foo F1. So foo F3, for example, on B2 and B3 should be removed, except that there is probably a typo there. And that's what the unit test check with this one. So I'm calling this, and I check that function bar B2, bar B3, foo F2, foo F3 are removed. That's for this sample. We have other edge cases where in your package you are using a scalar. For example, here I should not remove main bar x, which is using $x, which is using $foo. The risk here is to remove some stuff from foo, to clean up foo. Here also, when you mock function, you don't want to remove x, because x6 is used by ABC, which is used by myray. So this is also another unit test that covers this part. Same thing when you do a backlash and to get the link to that function there. You don't want to remove x6. So this is the kind of edge cases that this test is covering. Okay. Okay, we should probably have a look at the code. Yeah. So I'm going to, the idea is to, so I use now the same, I start from the script that Brian posted. I don't want to use moo there for this purpose, so I just use something lighter. But if you prefer using moo, just uncomment this and you will be able, it will work the same way. Just want some accessors on setters on these attributes. And the idea is that everything is going to be lazy. So we can build our object there. We have a document we are going to build. Just a method to convert it to a string. And then everything is going to be lazy. What we need to check is the and. Okay, so when we call the program, probably start here. This is the wrapper. When we call the program, we just say analyze new on this, the content of this file. Okay, and from there, we are going to we automatically remove the pod, and we are going to get the subs and remove them. Here. Okay. It's probably later. Okay. So the unused subs, get used subs. Okay. So to get the unused sub, we just need to know which subs are used and which subs are defined. Then we do the delta and we remove them. To get the list of used function, we have some helpers. We get the symbol, we get the list, and we get the bare words. We combine all of them, and this is our list of used function. Okay. So once we know all the used function, we do the delta here, unused. And for each of these functions, we are going to use PPI to delete them, to delete the node for us. And then we are going to write that PPI. So for example, what we can check is how we can get the list of functions using PPI. Here. So here on the document, we say find all PPI statement sub which are not neither begin check, unit or on block, okay? And then for all of them, I want to get the full namespace of the function name. I'm going to save it and return them. So these are all the sub-definition, statically, not the dynamic one. And so on for all of the others. Same thing for the symbol, except that I want to care about special symbol on the star. And I'm listing them. And then, so this is the concept of this. Probably have no time to go further there. So once we have simplified a script by removing some function, maybe we will end by unused statement. So we can also get rid of this by using a PPI script that will be able to detect extra use or require statement, but also detect missing ones, because some might be implicit at the beginning. So that we came with another tool to fix this. I will not be able to show this to you. So what kind of benefit all of this could have on your source code? This is a simple program that will display the hostname, get-hostname PL, and display the hostname of your server. Okay, the program itself is 12 lines, but it contains 7 dependencies, because warnings and strict are included. So once I run find unused subs on this program, it loops 5 times, and at the end it removes 16 functions, which consider useful in this context, and can get rid of 3 packages completely. And and then at the end I'm displaying also some extra result statistics. So 3 packages can be yanked. 1 was reduced to probably a few functions. On the other, we can only probably remove one out to 3 function. What does it look like? So this is the Fatpack version before and after. We can see that we in fact remove nearly 7,000 lines once we remove the unused function. No, okay, sorry, we remove 200 lines. So we reduce it by nearly more than 20%, 30% nearly, which is not bad. When we try to compile this program, we now have something 200K slower. And when we run it, because that's what matters also, when we run it, we are about 5 to 10% faster there after compilation. So this is a very simple program, but this is just showing what kind of impact you can have. All of this, is it really, really worth it? So yes, it's very fun to do, but should you use it? Probably not, because in most of the case, if you own your own servers, if you don't have thousands of servers, you probably do not really care about saving a few K on your process. Then if you are deploying your product to servers you do not own and you want to be as less intrusive as possible, then maybe that might worth checking your import first and then see if you can detect unused code. And it all depends how many time you are going to spend on this versus what you are going to save. So what's next for these tools? There are very, very simple set of tools. I'm not sure I can go very deeply inside the script that detect dead code. But one of the problems when you do PPI parsing is to detect code inside eval block. And you have 4 kind of quoted eval block, single, literal, double, interpolate. So they go by 2, but they behave differently. Might worth also checking PPI xref. That was advice from Sawyer to PPI xref will generate for you the cross-reference in your code base. Combining unused function and include discrepancy together might also be a good thing. I need to increase the functional test of this. Maybe packaging this, I'm not so sure. So far, it's only lives on GitHub. And you should also have a look at the Devel Quick Cover, which is doing it differently to detect dead code. And the last point is, if you want to get rid of unused code, in a perfect world, the easiest way will be to have one file per function. So it will be so much easier to detect unused code. This is, in fact, what you can emulate using autosplit or autoloader. This is the extreme. Of course, you do not want to do this in your code base. It's very ugly to have 1 PM per function. But on compilation, that's probably something you can try, at least. Yeah, so I don't know how many time. Yeah, OK. I've got 15 minutes if you want to go back on the PPI parser or something else. Yeah. OK.
So have you found any surprises after you have removed something, like you realize that runtime later in the run of the program you were doing some magical require?
The first thing that happened was function. That's why I said function. At the beginning, I was not handling function correctly. So I need special rules to detect function. And of course, if you are doing lazy loading, load at runtime, this kind of thing is currently not managed. But at the end, the goal of this is not to use it in production. Never. It's not, oh, I've got a program, I'm going to shrink it, and then I'm going to push to production. That's not the goal. The goal is that you have your program, you run this tool, it's like, oh, be aware that this module seems totally unused. This one looks like you're only using 20% of the function. So you are aware of this, and then you are going to have a look at your code base, and you'll see, maybe it makes sense to divide this module in two. Maybe this use statement here is totally useless. So you will be able to organize your code source better in order to have direct impact. And the thing is that you have a look at, for example, one script, you do this analysis, and you then improve your code base, but by doing this for one program, you're going to improve all your code base. All your script will take advantage of this. Yes?
So if you have like a whole bunch of different modules, and let's say that like 3 of them call data dumper and only 2 use it, will that point it out?
You will use data dumper only once. Oh.
Like if 2 of them use it and like actually make use of certain functions in there, and then another one just says use data dumper, that's shared memory, so it's really not impacting anything? Does it take that into
The problem is that your modules depend how they are used in your script. The second your script is using one module which is using data dumper, you need data dumper. If it's really using this function. But in the context of a specific script, if at the end you are bringing data dumper, but it will never be called, then it will detect it and be able to remove it.
Yeah, there's a companion app which you didn't get to include discrepancies.
Yeah, that's the one I was barely talking. I cannot show this one because it's not, code is not clean, in fact, there, but it's working. The idea is that using PPI, you can detect missing use or required use, because I think that's a very bad habit that was joining the previous talk, where you should not start using a function from a module when you are not loading it. You should not rely on a third-party module to load the module for you, because the day that module is going to be refactored, then, for example, data dumper will not be available in the scope of your module. So before doing any optimization, we need to clean our code base by fixing this. Once that was done, we had the rule to Perl tidy to make sure that it will stay clean, in fact. Then we can optimize and remove stuff. Yes?
Does it require that you stop importing them?
yeah, requires the same as use with, nearly the same as use with parents.
Does these scripts make it so that you have to?
Yeah, this script will say the require statement or the use statement is missing in this PM. Please add it. Or the reverse, you are using data dumper, but you are never using any function of data dumper.
I guess
It needs to see you make a full path call to data dumper, so you would have to call data dumper dump before it knows that you use something from data dump.
Yeah, we make it easier by doing this, but you can also check which functions are exported by data dumper and do the mapping.
You could enhance it, but right, it
Yeah.
does not do that. It does not do that.
Right now, it's assuming that all your code source is not importing, in fact. I don't know where I have it.
Those right at the beginning.
Okay. Okay. So all of this is assuming that all your code base is at the first part. It can be improved if you want to use module like this and use automatically import. It can be improved by detecting which functions are imported by this and then automatically add it.
But then you could have collisions.
Yes.
Yeah, you can, but usually you expect that the module doesn't have collision.
Yeah.
Right.
You will trust the developer.
I don't trust it.
Yeah.